Hello and welcome to this homework help video where we're going to talk about net force and Newton's second law. In this, I have a version of a problem that is similar to a problem that you would see in an online homework system, and I've just changed the numbers a bit, as you can see with the different fonts. Now, there's two parts to this, and we're going to head and tackle both of them, but what I'm not going to do completely is actually rank all of the calculations, rather just show how to do them a few times. Okay, so let's take a look and read the problem to get started. So we are told in part A, or rather asked, from greatest to least to rank the acceleration of the boxes. Okay, and we can go ahead and take a look at that. Oh, actually, I can see here that this should be part B and this should be part A. And so we'll go ahead and start with the correct part A right down here. Okay, so the first thing that we're going to do before we rank the accelerations is to rank the net force. It makes sense to do this first because you need to know net force before you know acceleration. Okay, and that all comes down to our two key equations, and here they are. So the first one is just the net force equation. Okay, so that equation, I'll call that equation one, says that F net, so that's like a subscript to tell us that this is the net force as opposed to the tension force or the support force or the buoyant force or some other force that has a name. So here it's just the net force. Net means total, like net income, and is also sometimes called the total force. So you might have a subscript of total. Also, sometimes you see it with the uppercase sigma, but we will worry about that, the Greek letter. Here, we're just going to call it net force, all right? And all it is just the sum of all of the forces on a particular object. So it would just be F1 plus F2. Now, there could be more, okay? You're not really going to see more in a class like this. So you're just going to have two forces, usually, two opposing forces. Sometimes those two opposing forces exactly balance each other out, which is a state of equilibrium. But more generally, you could have any number of them. So you could have a third force and a fourth force and so on. But it is just that. It's just the simple sum. Each of these have units of newtons. So every one of them is a force measured in newtons, such as 22 newtons or 5 newtons and so on. And you're just going to be summing those all up, okay? But direction matters. And what we want to consider for this problem is some direction that we call the positive direction. So all of the forces with their indicated arrow to show their direction, we want those all to either be positive or negative. So let's go ahead and call the positive direction the direction pointing towards the right, which is certainly the standard way of doing it. So I'll call that positive x. We could just call it positive because there's no x and y here. So x is just, whatever, right? I could call it q or anything, okay? But here we have positive x pointing to the right. So then all of the forces with their little arrows that point to the right, well, those are positive forces, such as positive 12 newtons. And any force that points to the left is a negative force, like negative 5 newtons, okay? And so then if we go ahead and go down to part A, mistakenly put at the bottom, then we can go ahead and do some example calculations for these different cases and just see what the net force looks like. So we would have, I'll call these different parts A, B, C, and D. So for part A, our example calculation would give us a value of 12, because I'm going to start with a positive one first. So I'm taking the one on the right. Typically we read left to right, but I'm starting on the right because I'm going to start with the positive. That's pretty standard. I don't have to. I could just as easily have started with a negative. But this way I can say, 12 and then plus negative 5 newtons, which of course is just the same as 12 minus 5. And so that is, and I'll make sure to label what I'm actually calculating here. This is the net force, okay? So that variable, because it's just, this is really just a single letter. This would be a single variable, as we call it, right? The subscript just denotes, the details about that variable. So essentially it's just F. So I'm saying that F is equal to 12 minus 5 with units of newtons. And then we know that 12 minus 5 is 7, okay? So there is a net force of 7 newtons, specifically a net force of positive 7 newtons, which you could also rightfully interpret or express as 7 newtons pointing to the right, which we call the positive direction, as you can see right up here. All right, so that would be the first one for part A. For B, if we're going to do net force again, and I'll be a little less thorough this time, then again, I'll start with the positive though. I'll do 15 newtons and then minus 10 newtons, so which that will just give me 5 newtons. I'm not bothering to put the positive because if there's no negative, we know it must be positive. The only times I'll ever put that in there is just when I'm calling special attention to it, such as I was in part A. And then we'll do F net for part C as well, because we're just doing it each time. And over here, I'll go ahead and start with a negative one, just to show you it doesn't matter, right? Because when you add things together, the order doesn't matter. So negative 10 newtons plus 15 newtons, and that's just going to give me 5 again, because it's actually the exact same forces, as you can see, right? These ones are identical in terms of their net force calculation. And then down below, we finally have part D. And on this one, we're going to have 15 and 5 as opposed to 15 and 10. And let's go ahead and put the negative one in front again, just for fun. So negative 5 plus 15, which is going to give us positive 10. Okay. And then if we wanted to rank these as we were asked, well, you can see that you just rank them as in, make sure to do it, read the directions carefully in a problem like this, especially if you're answering an exam or you're answering an online system, because it's not something accepted in an online system and you don't want to lose points on an exam. And I bring that up because here it specifically says that we want to rank from greatest to least. Right, so if you were to order them and read from left to right, you'd want to put the greatest one first. Sometimes you're asked to rank from least to greatest, right? So you just got to pay attention to how it's listed. All right, and then equivalent items that overlap. Indeed, we do have 2 equivalent forces of 5 newtons. So we'd have 2 of those, on top of each other, or however you want to represent it. I'll show you I said I wouldn't rank them, but now I'm going to go ahead and do it anyway. Because if we're going to have them from greatest to least, I'd rank it like this: 10 newtons. And then I'd have my 7 newtons, second greatest, and then the least, I would just show them as tied. So I'd probably put something like this, all right? Or if I was, basing them off the letters, I'd rank them like so. So we'd have D for the greatest, and then we'd have A, and then I would write for B equals C. Right, so that would be all kind of ways of ranking it depending on exactly how the question is asked, and I figured that might be helpful to point out. Okay, all right, so that is our first key equation. Now, if we go ahead and look at part B, then we have key equation 2, all right, and key equation 2 is simply F net, okay, so it's the same equation, not quite, equals M, that's M for mass, A for acceleration. Okay, so this rather famous equation is Newton's second law. And a lot of times you actually see it written as just F equals ma, but that's basically entirely incorrect and misleading, because if you just write F equals ma, it begs the question, what F, right? Is it one of 2 forces? Is it one of 5 forces? Is it always gravity? What force is it? It's just the net force, okay? In this case, it's, the sum of forces that point, forwards and backwards, right? We call positive x and negative x, but it could be any direction, so it could be 3-dimensional, 2-dimensional, and so on. But that's always what Newton's second law is. F net equals ma, okay? And there's vector forms of this and so on. This would be called the scalar form, which is just the numerical form. All right, and then we'll go ahead and take some example calculations of that. I'll go ahead and put our example calculations for part B right here. So I have another set of them. Example calculations. Okay. And let's, for fun, make it obvious that we have an arrow. So this is all for part B, and then these are all the calculations for part A. There we go. All right, so our example calculations then are just going to employ that second equation, none other than Newton's second law. All right, so that means that this is very much a 2-step process, because we have to still find net force. And then once we find net force, then as a second step, we set it equal to ma and then solve for A, okay? So what that looks like, right, if we're going to do an example calculation, again, call this lowercase a, b, c, and d, then for A, I'm simply going to have that F net equals 15 newtons minus 7, right? We're used to that. And let's see, 15 minus 7 is going to give us 8, okay? Then we'll take that 8 newtons, right? Because now we know that that's F net, and we'll set it equal to ma. So then we're going to have 8 newtons equals, well, we know M is 5 kilograms. Okay, so 5 kilograms. And kilograms are the base unit of mass. Okay, so if they're not in kilograms and you want to use Newton's second law, then you have to convert to kilograms. That's important to point out because it's not grams, which is important to remember and easy to forget. All right, so this is the base unit of mass, the kilogram. All right, just like the base unit of force is newtons. It's actually a derived unit, but we could call that it's based off of base units. The base unit of time is seconds. The base unit of temperature is Kelvin, and so on. Okay. All right, so 8 newtons equals 5 kilograms times A, okay? A is going to have units of meters per second squared, okay? Because that's one of the base units I forgot to mention. Distance is meters. And so then we just go ahead and solve for A, which involves dividing both sides by 5, right? Because that would be the way to isolate, I don't know why I put a dot there, it's just 5 kilograms, but that would be the way to isolate A, the variable A, the acceleration. Okay, so divide both sides by 5 kilograms, okay? And let's go ahead and pull up a calculator here, which I forgot to open. All right, let's do that. I can give you the decimal, which I don't remember off the top of my head, for 8 divided by 5. All right, so make some space for it over here. Okay, and so then I'm going to have A. When I'm solving for something algebraically, I mean, first of all, sometimes it's helpful when you're doing this step by step, is to go ahead and cancel it out to show that you have got A all by itself over here. And then when I rewrite it, I like then to put the A on the left-hand side to indicate that really that's what I was looking for and that's what I have solved for. And then I'm going to have 8 over 5. If you look at it, you might say, oh, well, now the units are going to be newtons per kilogram, which wouldn't be incorrect, but newtons per kilogram simplified to meters per second squared. And that's because the newton is it's the kilogram meters per second squared. So divided by kilograms, and all you got left are the meters per second squared. Okay, and so 8 divided by 5 as a decimal is 1.6. All right, so 1.6 meters per second squared would be our answer. Now I'll move my rankings for part A down here real fast, and I'll do one more example. I won't do all parts of this one because each one is a little bit more involved and want to wrap this video up, okay? And so for part B, it would be the exact same thing, again, for all is part B, but for the second one, what I called lowercase b of part B, which is this one here, then we're just going to have our net force again, which would be 12 minus 5, and then we're going to deal with the mass. Let's actually do one that doesn't have the same mass, so let's go ahead and jump to C, all right, the one with the green circles on it. So let's take a look at C, and this one, we're going to have F net equals 22 minus 5, so 22 newtons minus 5 newtons. I like to be thorough and always put my units. Okay, and so then that's going to give me a value of 18 newtons. Yep, 18, that's correct. All right, is that correct? 5, 2, actually 17. Because I'd have 2 and then 3 more, so 17 newtons. There we go. 23 minus 5 would be the 18. Okay, and then, so that's my F net. And then I'm going to have my 17 newtons, right? So this is Newton's second law now, equals MA. My A is 20 kilograms. So I have 20 kilograms. And there was no reason I had to put it in parentheses. I was just kind of calling attention to the units. So here I won't. Instead, I'll just put the little dot representing multiplication. And then I'll just put my variable A. And then we're going to go ahead and solve for A, which involves dividing both sides by 20, which of course will cancel out on the side with the A. So then we'll just have 17 over 20, all right? And meters per second squared, which is what newtons per kilogram becomes. And go ahead over to our calculator. I'm using Desmos and take 17 divided by 20, and we get 0.85. That would be our value for the acceleration of that block, okay? So greater net force, right, of 17 newtons, but because of its significantly greater mass, it actually experiences a smaller acceleration, right? Because you can see that, having greater net force does not necessarily mean greater acceleration because the inertia, which is to say the mass of the object, obviously plays a role as well. And so if we're going to rank these, we would say that the acceleration of the figure all the way over on the left is actually greater than the acceleration of the one that I called lowercase c. All right, well, that concludes this homework help video. I hope you have found it